Hey everyone, and welcome to this explainer. Look, if you're an accountancy student gearing up for the LCPA, you already know the deal. The MAS portion of the board exam, yeah, it's notoriously tough. But what if we completely flip the script? What if, instead of looking at all this abstract math as just another miserable chore, we treated it like a high-stakes, gamified strategy? Well, that is exactly what we're doing today. We are mapping out the ultimate game plan for conquering linear programming graphical solutions. We're going to wire this directly into your brain for long-term retention. We want this to stick with you not just for your quiz on Friday, but for the next 3 years until you sit down to crush those boards. So, let's get into it. So, here is the ultimate question we need to crack today. How do you visually solve a 2-variable linear programming problem without getting totally trapped by the examiner's tricks? I really want you to actively keep this in the back of your mind as we go. We aren't just punching numbers into a calculator here. We are visually mapping out a battlefield to find the absolute most profitable or cost-effective coordinate, all while dodging hidden landmines. Here is our roadmap for today. First, the core objective. Second, graphing the feasible region. Third, finding the optimum point. Fourth, exam traps. And finally, a LECPA study hacks review. Let's jump right in. Section 1, Core Objective, Visualizing Linear Programming. Let's lay down the foundation. Okay, so when you're dealing with 2-variable linear programming problems, say you're deciding exactly how many units of product A and product B to manufacture, you need a way to literally see your options. And the absolute foundation of this visual approach is called the feasible region. Think of this as your safe zone in a video game. It's the exact area on the graph where all your valid, winning coordinates live. Any point inside this shaded area, that's a combination that works perfectly without breaking any of the rules. But if you pick a point outside of it, no way. You've just created a totally impossible business scenario. And what actually creates those rules in the first place? Well, those are your constraints. These are the restrictions that limit just how far a manager can push toward their goal. Whether we're talking about limited assembly hours, a shortage of raw materials, or even just tight warehouse space. These constraints form the very boundaries of our minefield. They're the intersecting lines that box in our feasible region. Section 2, Graphing the Feasible Region. It's time to build the map. This is where you transform from an accountant into a full-on cartographer. To be lightning fast on the board exam, you've got to use cognitive chunking. Think of graphing as a quick 3-step combo move. Step 1, just temporarily swap out those less than or equal to signs for straight up equal signs. Step 2, find your intercepts. You just set your horizontal variable x1 to 0 to find where the line hits the vertical x2 axis, and then do the exact reverse. Finally, step 3, plot those 2 points, connect them with a straight line, and check the inequality to figure out which side is your valid safe zone. Boom, map built. Section 3, finding the optimum point. Let's secure that maximum profit or minimum cost. Okay, so you've got your map and your shaded safe zone. Now, out of all the infinite possible points sitting in that feasible region, how do we pinpoint the exact best one? We need the absolute maximum profit or the lowest possible cost. You basically have 2 primary weapons to pull off this shot. First, the corner point method, which means you calculate the exact value at every single corner of your safe zone. Or there's the ISO profit or ISO cost method, which is a bit more visual. You draw parallel lines to find the absolute furthest tip of the region. Knowing exactly when to deploy which method is a massive study hack when the exam clock is ticking. Let's look a bit closer at the corner point method. The really cool thing about the math here is that the optimal solution is always going to hide at a corner, an extreme point of your feasible region. It literally takes all the guesswork out. You just find the coordinates for every single corner, plug them straight into your objective formula, and, well, pick the biggest number if you want profit, or the smallest if you want cost. It's mechanical, it's reliable, and honestly, it's practically foolproof as long as your basic algebra is solid. And that brings us to weapon number 2, the ISO profit method. This one is super clever. Instead of testing every single corner, you just take a random, easy profit amount and draw an initial objective line. Then grab your ruler and slide that line perfectly parallel, pushing it further and further out from the origin. The very last point your ruler touches before it leaves the feasible region completely, bingo, that's your optimal point. It's an incredibly fast, highly visual way to get the answer without having to crunch the numbers for every single corner. Section 4, Exam Traps. Time to learn how to dodge the examiner's favorite tricks. Examiners absolutely love throwing in structural anomalies. Why? Because they reveal if you actually understand the core concepts or if you're just blindly memorizing steps. There are 4 specific exam traps you need to burn into your brain right now: infeasibility, unboundedness, redundant constraints, and alternative optimal solutions. Being able to spot these visual anomalies instantly, that's the secret sauce for that 3-year retention and surviving the LCPA. First step on the chopping block is infeasibility. This happens when the problem you're given is literally impossible. For instance, maybe you're required to produce a minimum of 50 units for a contract, but wait, you only have enough raw materials to produce 30. On your graph, this looks like lines pointing totally away from each other with 0 overlapping shaded area. Spotting this instantly is a lifesaver because guess what? There's no math left to do. It's a dead end from the start. Move on to the next question. Next up is unboundedness. Think of this as a fake managerial utopia. This happens when your feasible region just stays open forever, usually pointing out towards infinity. It mathematically implies your profit could just go up and up forever. Obviously, in the real world, that's impossible. If you see this, it usually means someone, either you or more likely the examiner trying to trick you, left out a crucial constraint like maximum labor hours. Then we have the redundant constraint. Now this is a pure decoy, tossed in just to waste your time. A redundant constraint is a line that sits completely outside the actual boundaries of your feasible region. Think about it. If you were to just take an eraser and rub it completely off the graph, the shape of your safe zone wouldn't change one single bit. So whatever you do, do not let it trick you into doing extra useless algebra. Finally, the alternative optimal solutions trap. Remember a few minutes ago when we said the optimal solution is always at a single corner? Well, here is the one exception. If your objective profit line happens to have the exact same slope as one of the boundary constraints, they're perfectly parallel. So when you slide your ISO profit line out, it doesn't just hit one corner. It perfectly overlaps an entire line segment. That means every single combination of products along that entire segment gives you the exact same maximum profit. Pretty wild, right? Section 5, LCPA Study Hacks Review. Let's do a rapid-fire bullet review. All right, let's lock all this into your long-term memory. You've seen the map, you know the traps. Now I want you to take a mental snapshot of this matrix. It perfectly pairs the 4 exam traps with their instant visual giveaways. No overlapping shading, that's infeasibility. Open forever, unbounded. A useless line sitting way far away, redundant. A parallel overlap, alternative optimum. If you can instantly map these visual cues in your head, you are going to blast through multiple choice theory questions in seconds, without even touching your calculator. And to wrap up, here are your non-negotiable study hacks for test day. First, never ever forget the non-negativity constraints. You literally cannot produce negative units of a product, so always keep your work in that top right quadrant of the graph. Second, corners are kings. When in doubt, calculate those extreme points. And third, and honestly most importantly, scan for visual traps before you start doing heavy math. Working smart is just as important as working hard. I'm going to leave you with one final puzzle to test your active recall. Just imagine this scenario. You are sliding your optimal profit line outward. It hits a corner, but as you look a bit closer, you realize the shaded area actually never closes. It just keeps going infinitely outward into open space. Which of our 4 traps did you just uncover? Master the why behind puzzles exactly like this, and I promise you the NMAS board exam will not stand a chance. Keep analyzing, keep visualizing, and happy studying, everyone.